Hello friends, welcome to my video channel. Myself Professor Vaishali Shinde from KKY Arts, Commerce Science and Computer Science College, Kakasaheb Nagar. It gives immense pleasure to explain the molecular orbital theory. In the previous lecture, we see the molecular energy level diagram for homonuclear diatomic molecules of second row element, for example Li2 molecule. In Li2 molecule, we see that it is formed by the combination of two lithium atoms, and each lithium atom has electronic configuration 1s2 2s1. Then we can calculate the stabilization energy of Li2 molecule by using the formula number of electrons in bonding molecular orbital into minus beta plus number of electron in antibonding molecular orbital into plus beta. Then we also calculate the bond order by using formula 1/2 into number of electrons in bonding molecular orbital minus number of electrons in antibonding molecular orbital. Then we see the molecular energy level diagram of Li2 molecule. Now today we study the molecular energy level diagram for Be2 molecule. This molecule is formed by the combination of two beryllium atoms, and each beryllium atom has electron configuration 1s2 2s2. The 1s orbital is lower in energy, so it does not take part in bonding. Thus, 1s orbital remains as non-bonding orbital. Only the 2s orbital with its one electron takes part in bonding. Since there are two atomic orbitals, they will form two molecular orbitals, that is sigma and sigma star. Here we see the molecular energy level diagram of Be2 molecule. While writing the molecular orbital electronic configuration of Be2 molecule, the presence of non-bonding 1s2 electron is shown by capital letter K. Why? Because these two electrons are present in the first shell, that is K shell. There are two beryllium atoms take part in bonding, so the letter K is repeated. The two electrons of Be2 molecule go to the bonding molecular orbital, and next two electrons in the anti-bonding molecular orbital. Then the molecular orbital electronic configuration of Be2 molecule is written as Kk sigma 2s2 sigma star 2s2. Then the stabilization energy of Be2 molecule can be calculated by using the same formula, that is number of electrons in bonding molecular orbital into minus beta plus number of electrons in antibonding molecular orbital into plus beta. And we say that the number of electrons in bonding molecular orbital is 2, while the number of electrons in antibonding molecular orbital is also 2. Then we put up these values in the given formula, that is 2 into minus beta plus 2 into plus beta, and we get 0. Then calculate bond order having again the same formula, that is 1/2 number of electrons in bonding molecular orbital minus number of electrons in antibonding molecular orbital. Again the number of electrons in BMO is equal to 2 and number of electrons in ABMO is equal to also 2. Then we get 1/2 2 minus 2 is equal to 0. The bond order as well as stabilization energy of Be2 molecule is 0. The bond energy is also 0. Hence Be2 molecule is not in existence. Then we see the next molecule, that is B2 molecule. This B2 molecule is formed by the combination of two boron atoms. Each boron atom has electron configuration 1s2 2s2 2p1. The 1s orbital is lower in energy, so it does not take part in bonding. Hence it remains as a non-bonding orbital. Only 2 2s orbital and 6 2p orbital of 2 boron atoms, that means total 8 orbitals, forms total 8 molecular orbitals. Here 2s and 2p orbitals of boron atom are close in energy, so they interact while writing the molecular orbital electronic configuration of B2 molecule. The presence of non-bonding 1s2 electron is again shown by capital letter K because these two electrons are present in the first shell, that is K shell. Here there are two boron atoms are combined, hence the capital letter K is repeated. The remaining 6 electrons of B2 molecular orbital following Afebo principle and Hund's rule of maximum multiplicity. First 2 electrons go to sigma 2s bonding molecular orbital and next 2 electrons go to the sigma star 2s molecular orbital. The remaining 2 electrons occupy pi 2py and pi 2pz orbital with the parallel spin. And we know that these two orbitals are degenerate, means what? Having equal in energy. Hence, the molecular orbital electronic configuration of B2 molecule is KK, sigma 2s2, sigma star 2s2, pi 2py1 and pi 2pz1. Here we see the molecular orbital energy level diagram of B2 molecule. Then calculate stabilization energy having formula number of electrons in BMO into minus beta plus number of electrons in ABMO into plus beta. Here in molecular energy level diagram we see that the number of electron in bonding molecular orbital is equal to 4 and number of antibonding electron is equal to 2. Then we put up these values, that is 4 into minus beta plus 2 into plus beta, and we get minus 2 beta. This minus 2 beta is the energy evolved for the formation of B2 molecule. Then we calculate bond order is equal to 1/2 number of electrons in BMO minus number of electrons in EBMO. We already see that the number of electron in BMO is equal to 4 and number of electron in EBMO is equal to 2. Then we get 1/2 4 minus 2, which is equal to 1. The bond order is 1. B2 molecule is exist in vapor state. It has bond length 1.59 angstrom and bond energy 69 kilocalorie per mole. There are 2 electrons are unpaired, hence the molecule is paramagnetic. Today we see the formation of B2 molecule and B2 molecule. Thank you.